In this video, I will solve question 1 of homework 4. In this question, we have already known that g of x equals to 2 when x is less than 0, and when x is ranging from 0 to 1, g of x equals to 0, and for x is greater than 1 and less than 2, g of x equals to minus x plus 1. Finally, for x is larger than 2, g of x is minus 1. The diagram of y equals to g of x should look like this. Now, concerning y is ranging from minus 1 to 2, the distribution function of fyy equals to 0 when y is less than minus 1. And if y is greater than 2, the distribution function of y should be 1. For y is ranging from minus 1 to 2, we should know that when y equals to minus 1, the probability of the y equals to minus 1 equals to the probability that x is more than 2, and it equals to 1 minus the probability that x is less than 2, and equals to 1 minus fx2. When y equals to 0, the probability that y equals to 0 equals to the probability that x is ranging from 0 to 1 equals to fx1 minus fx0. For y equals to 2, the probability that y equals to 2 equals to the probability that x is less than 0. And this will be equals to fx0. And for y is ranging between minus 1 and 0, the distribution function of fy equals to the probability that y is less than y, and equals to the probability that minus x plus 1 is less than y. And this equals to 1 minus the probability that x is less than 1 minus y. And then if y is ranging from minus 1 and 0, then the density function of fyy equals to fxx divided by the absolute value of derivation of g of x at x equals to 1 minus y equals to fx1 minus y. Then we can figure out the density function and the distribution function of y. The density function of fyy should be 1 minus the distribution function of fx2 when y equals to minus 1. And for y is ranging from minus 1 to 0, fyy should equal to the density function of fx1 minus y. This density function of fyy equals to fx1 minus fx0 when y equals to 0. And when y equals to 2, the density function of fyy should equals to fx0. Otherwise, the density function of fyx should be 0. And for the distribution function of y, when y less than minus 1, the distribution function of fyy equals to 0. And if y is ranging between minus 1 and 0, the distribution function equals to 1 minus fx minus y. And if y is greater than 0 and less than 2, the distribution function of fyy should equals to 1 minus fx0. Otherwise, the distribution function should be 1. So this is the answer for question 1.